Okay, so with regards to the formation of the Earth, the scientific viewpoint on the formation of the Earth, this diagram right here, even though it looks a little bit complex, actually kind of sums up everything pretty well. You've got the Big Bang right here, right? This giant explosion that that is said to have produced all the particles, all the matter that makes up the current universe. All right. Well, these nebulas, these dust, these particles, like I said before, start to contract together and form individual objects, whether they be stars or planets. Incidentally, when things contract, they tend to kind of spin, right? And as things spin, they wind up contracting into sort of disc-like shapes, and so that's why the model that's why we have the model for the formation of the solar system. The fact that you have the sun and then all these various different planets that are around it it's not very good right there, but in various orbits around the sun, but they're all generally on the same disk, on the same plane. That's because of that. Because as things contract, they start to spin. All right, and so you have things like the sun and the various different planets right here. And so then kind of begins the timeline of our Earth, 3.9 billion years ago. By the way, there's a lot of unexplained time in here. Obviously, 3.9 billion years, and then 14 billion years ago. There's a certain amount of uncertainty in there. But anyway, as this timeline starts, we now have the Earth itself. All right, and the Earth kind of solidifying, as it were, and then no oxygen at first, and then oxygen later on. We have what's called the Precambrian time period right here. This really is kind of what starts our geologic timeline. The Cambrian period is really one of the beginning periods where we have life, or that is some sort of fossil record. All right, Cambrian. So before the Cambrian period, it's called Precambrian. That is just kind of formation of the Earth. All right, then we have various different. We have single-celled organisms, and we have a little more complex things. And through biology, you probably talked about the ideas behind evolution and things. That is natural selection and that kind of thing. So things survive and then move from water onto land right here, and you've got more complex animals. You've got fish, and then land creatures. We've got dinosaurs, obviously, and then we get into some names that you may have heard associated with dinosaurs. The Triassic period right here, the Jurassic period, all right, like Jurassic Park. The Cretaceous period, that's where we had even more well-known dinosaurs like Triceratops and like the T-Rex and pterodactyls and such. And this is, it's hard to see, but it says Tertiary, all right, Tertiary period. And this is still kind of the Tertiary period right here with lots of little epochs in between until we have the current period, which is called the Quaternary period. And then we have things like humans and ships and buildings and space shuttles, that kind of thing. All right. So this is the idea behind, or this is, you might say, the timeline behind the formation of the Earth. All right, all the way back to the Big Bang. So the idea behind the formation of our sun is that it formed out of a result of a supernova. Now, like I said, a supernova occurs when a star, a very large star, collapses on itself because it can no longer, it has no longer enough fuel to create fusion to create the outward explosion, and so gravity takes over and collapses it all at once. Well, very much like, let's say you have two baseball bats, one in each hand. If you were to smack them together, they would both rebound back out. And that's what happens with supernovas. The rebounding back out is the giant cloud of glowing dust that you see. But what you don't see is that in the very center right there is a lot of really, really dense matter. It's believed that possibly the sun formed out a result of that. All right, and so all this cloud of dust and particles and stuff was really what wound up forming around the sun. This would be, like you might say, the seed of the sun, and this would be what we call a nebula. Nebula, I think it's either Spanish or Latin, literally means cloud. All right, And so as this starts spinning, as this whole system starts spinning, you have this flattening out into kind of like a disc or like a pancake shape. All right, very simple atoms, hydrogen and helium, the two of the simplest atoms that are there. But as these join, and they can actually create other kinds of denser kinds of atoms that we would see today. So as this whole system starts to spin, it creates this disk, all right, around the sun right here. You have certain particles trapped in rings around the sun, right? And the particles that are on those rings start to pull together and form more dense lumps of particles that eventually are believed to have formed the planets. All right, and so even after the Earth was formed, according to this theory, you still have some other particles that are still out there that have not quite yet been attracted to the Earth, and so the Earth is being bombarded by all these particles, all this dust from this nebula, and the Earth is constantly pelted with these things. Not so much anymore because a lot of these particles have already been attracted to one planet or another, but early on, the Earth was pelted by millions or even billions of these per day, if not per hour, all right? Because not all these particles have yet been attracted to a planet. The process of them being attracted to a planet by gravity is what causes them to move through the atmosphere. This next picture right here is out of a solar nebula, all right? Now, it kind of looks like you have this cloud of gas and these stars are inside of it. In reality, these stars, these big stars here, are actually closer to us. This cloud of gas is very, very, very far in the background right there. These are stars that are sort of in the foreground. But it's this cloud of gas, this nebula, that is believed to be kind of like, you might say, the nursery or the well, you might say like the incubator, as it were, for stars, or these clouds of dust. Like, look up here, right here, these kind of fingers of dust that look a little bit denser. You can imagine dust starting to pull together in those because of gravity and form either planets or stars. So this is a solar nebula, and there's one or two that I'll point out to you that you can actually see with the naked eye. Okay, so according to the theory that we've been talking about, we now have all the planets of the solar system and the sun as well that are believed to have been kind of pulled together or congealed out of this nebula, this cloud of gases. This is certainly not to scale. The planets are not this far apart, but it is to scale size-wise. Mercury is about 1/4 the size of the Earth. Venus and Earth are about the same size. Earth is slightly larger. And Mars is about half the size, or you might say half the diameter of Earth. Jupiter, of course, the king of the gods, as the Greeks, or I think it was it wasn't the Greeks, it was the Romans believed, is certainly named that because it's the largest planet. And if you look at Jupiter's great red spot right there, our Earth is about the size of that red spot. That red spot is like a hurricane-like rotating storm. And so just imagine a storm being the size of the whole Earth. It's pretty terrifying. Saturn, right here, slightly smaller in diameter than Jupiter. And by the way, I should mention that these first four planets, Mercury, Venus, Earth, and Mars, are called the terrestrial planets. Like terrain or terrarium, it has a solid surface, like it's got ground. All right. Jupiter, Saturn, Uranus, and Neptune are all called gas giants. They're giant spheres. They look like they have a smooth surface there and there and there, but they're actually smooth spheres of gas. So you could not actually stand on these planets. You would fall through clouds and clouds and clouds, and getting denser and denser, and there might be some sort of liquid or even some sort of solid down at the center somewhere, but you would be crushed into oblivion even before you got there. So Jupiter, Saturn, Uranus, and Neptune are all made of gas. Interestingly enough, of course, well, we know that Saturn has the rings, and you can even see them with the naked eye. If you look at Saturn in the nighttime sky, it looks like a football shape rather than a single dot. But interestingly enough about Saturn, the gases that Saturn is made up of are so light, that is helium and hydrogen, that the whole planet of Saturn as a whole is so, you might say, undense, or the density is such that it would actually float on water. If you had a giant cosmic bathtub, and you put water in there, you threw Saturn in there, it would actually float, which is kind of interesting. Uranus, of course, that's everybody's favorite planet to talk about. Also, interestingly enough, it is made largely of methane. So there you go. Make your own jokes about that. Neptune, it's kind of a pretty color. It's like a deep blue, which I think is appropriate why it was named for the king of the ocean, the Roman king of the ocean, or the god of the ocean. And then, of course, Pluto. Of course, Pluto is no longer considered a planet. It is called a minor planet. And we found some other minor planets as well that we can talk about in class, and I can show you, too. There's a number of things about Pluto that makes us think that it did not form at the same time as the first 8 planets. But it's still there. Nobody blew it up. It's still there. It just has a different designation. So these are the relative sizes of the planets or minor planets in our solar system. But that's not the only thing that is in our solar system. There's also thousands and thousands of asteroids. All right? And asteroids are basically just rock, sometimes metallic substances, many of which exist between the orbits of Mars and Jupiter. And as we look at the distance of the planets in class, there's a big space between Mars and Jupiter. The first 4 planets are very close together, and then they start to get really spread apart. But there's a ring of asteroids that we call the asteroid belt that exists between Mars and Jupiter, for the most part, just orbiting around the sun peacefully. But sometimes they collide and go careening off in different directions, and we have these asteroids moving through the solar system, crossing the paths of planets, which could certainly prove problematic if a planet gets in the way. As these asteroids hit each other, they break up into smaller bits called meteoroids, and that just means that it's a rock as well. And but when a meteoroid starts to enter the Earth's atmosphere, it's called a meteor. All right, we call them shooting stars. Now they're obviously not stars; they're pieces of rock. But as they move so fast through the atmosphere, they create a lot of heat and they start to burn up. And so we say, hey, I just saw a shooting star. They last very, very briefly. By the way, meteors, in order for you to see a shooting star, they need to enter the atmosphere about the size of a grain of rice. So they really are not that large, but they're so bright that you see them even from the ground. And there's also comets as well. These are different things. These are bits of, or large chunks, I should say, of ice and rock that are kind of like asteroids, but they orbit the sun kind of in their own special oblong path. And when they get close to the sun, the sun's energy kind of blows the ice and kind of vaporizes the ice off of the rock and causes it to create this sort of tail right here. And so the place that a lot of comets form is called the Oort cloud, and it's way beyond the edge of our solar system, a place called the Kuiper belt. But these are some of the various different things in our solar system aside from planets. Here's a table that kind of describes the difference between all of those. I'll let you go ahead and read that. And here is our solar system and sort of the relative distances. Notice how the inner planets are very close together, and Jupiter, Saturn, Uranus, and Neptune get very far apart. And then we have the Kuiper belt out here, which is where a lot of these comets come from. This is a comet that came by in 1997 called Comet Hale-Bopp. Oftentimes they're named for people who discovered them. And one interesting thing about Comet Hale-Bopp was that it spawned a cult that the cult leader believed that there was a spaceship following behind this comet, and the only way to get on the spaceship that would take you to heaven would be to drink poison, and then you'll be transferred up to that spaceship following the comet, and then you'll be able to escape Earth. Well, that didn't end too well, but that's just what they thought. So that's Comet Hale-Bopp, and comets have really kind of spawned all kinds of crazy ideas over the years, but that was one that was more recent. So, like I said, that didn't work out too well. All right, that's going to be the end of Section 1 right there. Section 2, we're going to be getting into actual impacts and airbursts, but for the time being, that's kind of a sort of our solar system in a nutshell. And I'll thank you for watching, and I'll see you on the next one.